So this is 6.4 in college trigonometry, equations involving inverse trigonometric functions. This is the last section of chapter 6, and then that's pretty much all we're going to learn in this book. The rest of it is using what you have learned for some for some other stuff. But anyway, I guess chapter 7 we get into some new things, but nothing as complicated as what we've done in chapters 5 and 6. So it eases up a little bit, which is nice. Anyway, lesson 6.4, we're just going to do the first 3 examples. I'm going to skip example 4. And the assignment is 1 to 19 odd and 23 to 37 odd. But let's throw out 23 to 37 odd. Let's just do 1 to 19 odd. And let's just get started here. Example 1. We have, what do we have? Get to the right page here. Y equals 3 cosine 2x, and we're solving for x here. Alright, so what we have to do is we have to isolate the x. We have to just do regular algebra and get rid of everything except the x on one side of the equal sign. So we're going to divide first of all by 3. So I get y over 3 equals cosine of 2x. Okay, we can't do anything with that 2 because the cosine is in front of it. So that means that we're kind of stuck with it. So what we're going to do is we're going to move the cosine to the other side of the equal sign. Now the format for doing that, I can teach that to you, but I guess I'm just wondering what the point is to teach that to you. So I'm just going to tell you what happens here when we move that cosine to the other side. It turns into a cosine to the negative 1. So if we move the cosine or any of our trig functions across the equal sign, it just changes to the arc cosine. Or if we move this to this side, it changes to just the cosine. So the negative 1 comes off of it. So that's just pretty simple. Just to follow that procedure there, it'll make your life easier. Actually, what we're doing here is we're dividing by cosine here and dividing by cosine here. So here I am teaching it to you. And the cosine is in the denominator, but we move it up, so then it becomes a negative 1. So that's back algebra 2-ish, algebra 1-ish when we did all that. So anyway, that's what happens, but anyway, you don't have to worry about that. Just know that when you cross signs with a trig function, it either goes from a cosine to a negative 1 or a negative 1 to a cosine. It goes from an arc sine to a cosine or a cosine to an arc cosine. So anyway, all that rambling to give you that there. Then let's see, we're going to divide by 2. Now we can divide since we don't have a cosine in front of there. And we end up, this is 2 over 1, or 1, or invert and multiply, and we get 1/2 cosine negative 1 y over 3 equals x. Okay, so at this point we are done. We found out what x equals. So x is actually, because we have an x and a y and we have one equation, obviously we can't solve for x and actually get a number. We're just left with an equation because of this y. But what we've got is there is an angle that which is x, where I take the arc cosine of the ratio of that angle and multiply it by 1/2, and I'm going to get an x value. If I knew this y value here, I could actually get a number here, but since I don't have a y value, I'm stuck with just writing the equation here. So it's kind of like back when you were doing algebra 1 and 2, where you had 3y equals 2x plus 4, and you were asked to solve for x, and you had to subtract 4 from both sides, and you get 3y minus 4 equals 2x. You divide by 2, and you get 3y minus 4 over 2 equals x. And that's as far as you could go because you don't know what the y is, so you're stuck with that. as an answer. You just solve for x, but you still have kind of a messy thing here. It's the same thing over here. We had something goofy and an x and a y. We just solve for x, and we have this over here because of this y. We can't actually say x equals 12 or some number because we don't know what y is. It's the same thing we did here. Okay, so this is what you did in the olden days. This is what you're doing now, is you're just solving for x. All right, so let's go and look at example 2. Example 2 says that we have 2 arc sine, or you could have written it as sine of -1, doesn't really matter, arc sine of x equals pi. Okay, so what we're doing here is we're solving for x again. And in order to do that, we're going to first of all divide by 2. And that gets rid of that, and that gets rid of that. So now we have the arc sine of x equals pi over 2. What we're going to do is we're going to move the arc sine across the equal sign. And remember, when we do that, it just changes to sine instead of arc sine. And we get that. All right, so what we've got here, what this says is, there is an angle that when I take, and the angle is pi over 2, which is a 90-degree angle, when I take the sine of that, I'm going to get a ratio x. So I can actually solve this because I know that this is a 90-degree angle, so if I take the sine of 90 degrees, I get 1. So I get the answer of 1. So if we look at our original problem, which is 2 sine -1, so our arc sine x equals pi. What this is asking for is, what is the angle? Whenever you have an arc sine or an arc cosine or an arc tan or something like that, when you have the -1 up here, this is the first thing you're going to say is, what angle has the ratio of x that when I multiply it by 2, I'm going to get pi. Okay, so that's what that's asking. So let's look at this. We just found out that x is 1. So what angle has a ratio of 1, and we figured that out, this is a 90-degree angle, so a 90-degree angle times 2 is a 180-degree angle, and if we change that 180-degree angle to radians, we get pi. Or if we say, what angle has a ratio of 1? Well, that angle is pi over 2, times 2 is 2 pi over 2, which is pi. So it's just knowing the words, knowing what in the world you're looking for, that is going to really help you here. All right, so let's do one more, example 3, and we'll be done with chapter 6. All right, so we have cosine -1 x equals sine -1 to 1/2. All right, so again, this is my ratio. What angle has this ratio? Or in other words, what angle gives me 1/2 when I take the sine of it? Sine of some angle is 1/2. Now the book uses, again, the mu symbol there in order to do some substitution. I'm not going to do that. I think in this lesson, this exercise or example, the mu sign just adds confusion there. So let's go ahead and see what we've got here. Let's just look at this cosine -1 of x. So that's actually saying the cosine of some angle, we'll call it theta, is going to equal x, is going to give me that ratio. It's the same as the sine of that same angle that's going to give me 1/2. So, didn't really do anything except look at both sides of the equal sign and switch it to cosine and sine instead of the arc cosine and sine. So what I'm looking for is an angle here that gives me a ratio of 1/2. And if I graph this, sine, it's positive, so it's going to be in the first or second quadrant. So let's draw it here in the first quadrant, first of all. and opposite over hypotenuse, which makes this the square root of 3, which means this is a 30-degree angle. And if I look at it in radians, it's going to be pi over 6. But let's keep it as a 30-degree angle here. So the sine of 30 degrees equals 1/2. Now I had mentioned that we're talking about the first or second quadrant that the sine can be positive in. Problem is, these two are going to have to be the same. Well, cosine is not positive in that second quadrant, so that makes us stuck in just the first quadrant. So where sine and cosine are both positive is only in quadrant 1. So that's what we're going to be looking at, is just this angle right here. So if that is the angle, or the triangle that we're looking at, and the sine of 30 equals 1/2, so I know I'm looking at that triangle, what's the cosine? Cosine of theta is going to be adjacent over hypotenuse. So I get the square root of 3 over 2. So what does all this tell me? This tells me that a 30-degree angle is over here, so therefore this must also equal a 30-degree angle, right? Because it says they're equal to each other. So the ratio for this 30-degree angle of a sine is 1/2. The sine of 30 degrees is 1/2. What is the cosine of 30 degrees? Pi, or square root of 3 over 2. So in order for these two to be equal, I have to know the ratios. Well, the ratio for the 30-degree angle for the sine is 1/2, 1 over 2. The cosine ratio is square root of 3 over 2. So these are both 30-degree angles, so they're equal, because this says what angle has a ratio, and this says what angle has a ratio. So I'm looking for the two angles. The two angles are 30 degrees. I'm sorry, I feel like I'm just saying the same thing over and over, but I want to make sure you understand. But what I'm looking for x is the ratio. What ratio gives me a 30-degree angle? Well, the ratio for the cosine is the square root of 3 over 2. They gave me the ratio over here for sine. So the ratio for sine is 1/2. The ratio for cosine is the square root of 3 over 2 in order for these both to be 30 degrees. So anyway, that's 6.4. That's it.